All right, let's look at this warm-up problem. All right, so basically we're reviewing three things here. First one, so I want you to think like this. Even if you wrote the answer down, don't tell me the answer yet, because what I'm hoping you did when you looked at that one, you recognize that each segment is going from what to what? Vertex to midpoint. Does everybody agree that's showing you that it's going vertex to midpoint? Everybody good on that first? So therefore, that's how you know it's a median, because a median goes vertex to midpoint. Now, POC is supposed to mean point of concurrency. So let's do this first before we write it down. There's different points of concurrency. What does point of concurrency mean? Yeah, so any three lines meet at one point, that's a point of concurrency. For medians, the point of concurrency is the centroid. So our first one, we got median, centroid. What's special about the centroid? Two things. Anybody remember any of them? The center of gravity. Okay, so it is a center. It's a center of gravity. That means it would balance the entire triangle. And then what ratio does it break up the median into? 2 to 1. So it makes a double part and a single part. Okay, now the next one over, what do you think they're showing you there with those tick marks? Saying they're equal. You guys agree it's saying those are equal? Now, it's not really, I don't know if it's drawn out exactly how I would like for it to be, but what it's basically saying, that point in the center, you guys agree it's saying it's equal distance from each side. You guys agree on that? That's the one we learned last time we were in there, so that's an angle bisector. Now, they could have made that one easier and made you show the angles are equal, but basically an angle bisector is equal distance from each side, so that has to be an angle bisector. So the point of concurrency is the in-center. And we already said what's special about it is equal distance from each side. All right, next one. Garrett, you with me back there? All right. Last one, what are they drawing in on each of those? It's going from the vertex straight down perpendicular, so that means it's a height, but what's our fancy word we're going to use? Altitude. So it is a height. They're just not calling it a height. They're calling it an altitude, but essentially they're the same thing. And on this one, there is a point of concurrency. It should be the orthocenter, but we didn't learn anything special about it. So on that one, all you've got to remember is the name of it. You don't have to remember anything special about it, okay? What's the one segment that they left out of here? Anybody know? And there's a reason they left it out, because it does not have a point of concurrency. What's it called when we go midpoint to midpoint? Mid-segment. Okay, so that's, you don't have to write it down, but that's the other one that we've learned. That's not on here right now to make 4. Mid-segment goes midpoint to midpoint. And we did learn two things about the mid-segment. The mid-segment and the base are what? Parallel. And the mid-segment is half the base. Okay, that's the two things we learned about a mid-segment. And then what today we're going to do is we're going to do the last one, a perpendicular bisector. Okay, so think about this word first. Perpendicular means what? Makes it what angle? 90, right angle, 90-degree angle or right angle. Second, it says it's a bisector, so it's doing what to a side? It's not doing it to the angle, okay? It's doing it to the side, it's cutting it in half. Which means, you guys agree, would have to go through the midpoint. So if we look down here, go down to perpendicular bisector definition, a line or segment that is perpendicular. Once again, you don't have to write the word perpendicular in there. What's the symbol? Upside down T to a side of the triangle and bisects that side. One endpoint of a perpendicular bisector is always a midpoint. Now this, they're saying the other endpoint, it could be a vertex, but most of the time it's not. So everybody got that? So I think you're better off to write the other endpoint could be anything. Doesn't matter where the other one goes. It's like angle bisector. So an angle bisector and perpendicular bisector, it does not matter where the other point goes. What is important is the angle bisector bisects the angle. The perpendicular bisector bisects a side. Does that make sense, everybody? So it could go anywhere. Okay, now go down to number 1. Okay, I'm going to give you a hint. That segment is more than one of the ones we've talked about. It's kind of a special case. Somebody tell me one thing you think it is. What'd you say? I couldn't. What'd you say again? I'm sorry. Altitude. You guys agree it could fit as an altitude? Does it go from the vertex straight down 90? So let's write down altitude would work. We got 2 other ones we could put in there. Is it an angle bisector? It's an angle bisector, isn't it? Is it a median? It's also a median because it goes midpoint to vertex, doesn't it? So there's 3, right? And then the one we learned today, would perpendicular bisector also fit? Yep, so let's write that one down. So all 4 of those fit in this category. Median, altitude, angle bisector, perpendicular bisector. So clearly this is kind of a special triangle, isn't it? What kind of triangle do you think this is? It's isosceles. So for this to happen, these 2 sides have to be the same. Because what basically happens is if these 2 sides are the same, this altitude will also be the median, the angle bisector, and the perpendicular bisector. Okay? All right. Now go over to number 2. This is probably the most important one out of those 2 because this is the new thing we're learning today. All right, so I'm going to ask you a question. First question is, if I want to make something perpendicular, what has to be true about their slopes? Okay, so to be perpendicular, slopes have to be opposite reciprocals. You guys agree with that first? Okay, now we know a perpendicular bisector goes from midpoint perpendicular, correct? So let's do this. If I look at this bottom side here, this goes from 0 to 8, so where would be the midpoint? 4. So 1, 2, 3, 4. So boom, I put a point there. Now this is an easier one to find perpendicular because obviously if we have a horizontal line, vertical is perpendicular, right? So we would just go straight up. Does that make sense, everybody? So if I wanted a perpendicular bisector to this side, I went to the midpoint. Everybody knows that's 4 is the midpoint. Does that make sense? Then I would just go straight up from there and make that 90. Okay, anybody got a question so far? That was kind of that. Started with that one because that's the easiest one to do. Now the other ones are not hard if we understand this opposite reciprocal and we understand how to find the midpoint. Now remember when I told you this goes up 1, 2, 3, 4, 5, 6, doesn't it? So if I just went up half of that, 1, 2, 3, and straight over, you guys agree that would be the midpoint. So anytime you're on a graph, you can do that visually. Just go halfway. I could have done the same thing with the bottom. This is going over 2, isn't it? So if I went over 1 and straight to it, I'd still be at the midpoint. So now for this line here, AB, okay, the slope of this line is 1, 2, 3, 4, 5, 6 over 1, 2. You guys agree with that? So the slope right now is 6 over 2, which is 3 over 1. Okay, let's write that down. So the slope of AB is up 3 over 1. So if I'm going to draw in the perpendicular bisector, I want my slope to be opposite reciprocal of that, right? So for the perpendicular bisector, I'm going to flip that. And since that's positive, make that negative. So does everybody see where I got negative 1/3 from? That's very important. Now I'm going to use that to draw in my perpendicular bisector. I know one point is right here, don't I? Well, if I know the slope is that, if I just go down 1 over 1, 2, 3, you guys see what I'm doing there? And if I wanted to put another point just so I can draw it straighter, go down 1 again, over 1, 2, 3. I'm drawing that right through that line, like so. That's the perpendicular bisector there. All right, so let's do this. Draw that in. And then before we go to the next one, let's make sure we understand what we did. Okay, has everybody got it drawn in? So here's what we did. Recap real quick to make sure this is sinking in. So for a perpendicular bisector, I went to the midpoint, right? Is everybody good on finding the midpoint? Then once I had the midpoint, I put a point there. Now I find the slope of that line, because if I want it to be perpendicular, I have to find the slope, make it the opposite reciprocal. Now I use that slope to draw in my other one. Everybody good? Now, technically, I'm still going to do this side, but where should this one go through? It should go through right there, shouldn't it? Okay? So let's find the midpoint. You guys agreed that from here to there, I'm going up 6. So half of that is 3. So if I go up 1, 2, 3 and go straight over, I should be right there, shouldn't I? Put a point there. Okay, has everybody got that midpoint on there? Now, we need to know the slope of this one, don't we? Which is what? BC. So the slope of BC right here is 1, 2, 3, 4, 5, 6. I'm going up 6. Then I'm going left. 1, 2, 3, 4, 5, 6, right? So you guys agree the slope, oops, is negative 6 over 6. Because I went up 6, left 6. So that slope is a negative 1 over 1, right? So my perpendicular bisector slope has to be flipped, which is still 1 over 1, but it's going to be a positive 1 over 1. Now, if I'm going from here, so first, everybody with me on the slope? Now, if I go up 1 over 1, I could do that, then draw it. But remember, if I go down and left, that's still positive. So basically what's happening is down 1 over 1. See how I hit that point, which is good because it should have. That means that's perpendicular. And we found that's point of concurrency right there. All right, so when you get that drawn in, it says at what point do they intersect? Looks like they intersect at 4, 2, don't they? That point is called the circumcenter. So that point is the circumcenter. All right, now here's what we're going to do on this. Turn to the back of the notes now. What I want you guys to do, I want you to watch, and I'm going to show you something up there real quick, and then we're going to fill in that bottom box. But here's what I want to point out first. Okay, you guys remember when we did, okay? Now stay with me here. Angle bisector, we said it met at the end center, right? And it was equal distance from each side. So what that meant was you could draw a circle from that center inside the triangle. That's why it's called an end center. Okay, circumcenter, it comes from the words, what does circumference mean? It's to go around something, okay? Well, what the circumcenter is going to end up being is it's the center of a circle that you could circumscribe around the triangle. All right? Now I'm going to do this. I'm going to draw in two perpendicular bisectors here. So you guys watch this. Later, you're going to have to do this, but you can come back and watch this video. But we've already done a perpendicular bisector before. If I wanted to perpendicular bisect this side, I'm going to go from these 2 points, and I'm going to make an arc like that, okay? So if I go to this other point, and I made an arc like that, okay? This point and that point right there, if I draw that line in there, that's a perpendicular bisector. Now I'm going to keep my compass just like it is because I want to draw that in first. All right, so I'm going to get this straight edge. Grab a marker. And I'm going to draw that in. Maybe I'm going to draw it in. There we go. Now I'm going to draw it in. Son of a biscuit eater. All right, there we go. So I drew it through that point and that point. Does that make sense, everybody? Which means that's got to be perpendicular and it's bisecting that. Okay? Now here's where I said I was going to cheat. Remember when I made this arc right here? See how I made it big? I'm going to use that as my arc from this point, and I'm just going to make an arc from that point, and now that will be the bisector over there. I'm trying to be as exact as I can because I want to show you something here in a second. So when I draw that one in, they're going to meet at this point right here. They meet right there at that point. Okay, so does that idea make sense to everybody so far? That's how you could draw in a circumcenter. Now over here we did it from a graph, right? We found that point, that was the circumcenter. This one I did the construction. But what that point is, it means it is equal distance from each of these vertices. So the reason it's called a circumcenter is because it's the center of a circle. Now, if I did this perfect, this will work out perfect. The odds are not good, but we'll find out how I did. If I put my point here, and I put my other pencil on one vertex, okay, like so right there. If I did it perfect, when I come around, oh shoot, son of a biscuit eater. Okay, you guys see how that circle goes around the triangle? That's why that's called a circumscribed circle. Does that make sense, everybody? That's why that point is equal distance to each vertex. Okay? So let's write down what we just discovered here. Go down to the bottom. So it says the circumcenter is equal distance to the vertices of the triangle. So PA is equal to PB, and it's also equal to PC. So on that bottom example, that P is the circumcenter. All right, last thing I want to just show you real quick. Once you write that down, look back up here. So just to give you a bigger picture of like where they might give you a problem or ask you this question. All right, let's picture those are 3 roads. 3 roads, 3 water pipes, something like that. Does that make sense, everybody? So there are 2 things that could happen. If they said they wanted to put something that was equal distance from each road, which center do I want? Do I want an in-center or do I want a circumcenter? So if I wanted something that was equal distance to each road, Evan, what do you think? Go with the other one. In-center. Now here's why, because we're reviewing the difference in angle bisector and perpendicular bisector, okay? Angle bisector gives you the in-center. The in-center is equal distance to each side. So if you were doing a problem where I wanted to put something equal distance to each road, I would draw an angle bisectors, because angle bisectors meet at the in-center, which is equal distance from each side. If they wanted to put something that was equal distance from each junction, you guys understand what I'm saying now? Now we want something that's equal distance basically from the vertices. That's the circumcenter. Then I would draw in the perpendicular bisectors. Everybody see the difference in the 2? Okay? So a problem like that's going to come up at some point. All right, so what you're doing now is you're going to work on the practice. I am going to hand back the quiz so you can do quiz corrections. We will go over questions on lessons 4 and 5 and 6. See if you got anything you want to ask. Then we'll pick up that lesson there. I'll let you work on that. And then today we're actually going to do the quiz at the end of the hour. Does that make sense? Lasts like 12 minutes of class. Okay?